Hi, I'm Paul Stathis from TRC. Welcome to our Heat Pump Boss series, Level Up Your Heat Pump Installs. We've got the tools, tips, and how-tos that will help make you an expert heat pump installer. Today, we're going to focus on real-world indoor unit equipment placement. Let's dive right in. In this video, we will analyze real-world indoor unit equipment placement scenarios. We'll see where problems can arise from poor planning or simple lack of communication in the design phase. Let's start with the first real-world homeowner complaint. The homeowner stated that he was always cold in the kitchen and pantry and had to constantly run his backup heating system. During walkthroughs, we found poor indoor unit head placement. The head unit was placed off-center and distributed crosswise in a narrow room, separated from the remainder of the space. The ductless head isn't just off-center, it's also blowing directly into a small dividing wall. That wall became a physical barrier that was trapping the air in a tiny pocket instead of letting it travel the full length of the home. So even though the head is putting out warm air, the air never reaches the kitchen and pantry. The problem wasn't with the heat pump, it was the air distribution never getting to the back of the space. As we begin to think through solutions, we identified 4 key options. First, work with the head unit's available features to try to fan air back into the kitchen. Here, we would simply adjust the fins on the indoor unit, direct them in a position that gets airflow to the desired space. Similarly, there is an option to add a secondary room fan, something to help move the air that's sitting adjacent to the small wall. In this scenario, the fan would pull the heat out of this corner of the room and push it into the kitchen and pantry. Third, there's an option to install a remote temperature sensor in the kitchen. This would force longer run times. The system would stay in heating mode until the heating demands are met in the kitchen and pantry. Lastly, we can physically move the actual head unit. The unit would be moved so that it no longer blows air into the wall in front of it. Its new position would allow it to directly push air into the kitchen and better equip it to move heat around the interior wall. Let's say, however, there is a window in the way and there isn't any mounting space available. Not to worry, there's still options. You can choose to install a ceiling cassette or floor-mounted head instead. Now that we've seen how poor placement can affect airflow inside a home, let's look at another example. This next one started with a great design on paper, but things changed during construction and the final install location created comfort complaints. In this example, the residents made clear that the system just wasn't heating the main living area and that they had to constantly turn the thermostat up to compensate. Now what's interesting here is that we started with a great plan during the design phase. The head's location was selected carefully, the airflow paths were determined, and the layout would have provided unobstructed distribution across the entire space. What ultimately led to complaints was due to unseen obstacles during the build phase. Multiple ceiling cassettes were moved to accommodate the changes, and there was little thought of new distribution concerns. The result was blocked airflow and hindered distribution. Again, the unit is working great, but the placement isn't doing it justice. This example is more about communication during the building process and ensuring the design criteria are met. When there is a need for adjustment during the building phase, there still needs to be thought regarding distribution. Thanks for diving in with us on indoor unit equipment placement. Remember, we're here for you at cleanheatconnect.ny.gov with more videos, resources, guides, and best practices. Hope to see you in our other sessions as we complete better installations together, one project at a time.